next speaker is Reza Mohamed, and he'll talk to us about stacking and processing astro images. Go ahead, Reza.
Good evening, folks. My name is Reza Mohamed. I live in Toronto, Canada, and I'm a member of the Royal Astronomical Society of Toronto. Since I joined the society a few years ago, I've benefited far more than I've contributed. So this presentation is just a small token of my appreciation and a way to give back. I've recorded a video explaining how I stack, process images of M45 Pleiades using Deep Sky Stacker, Sequator, and Photoshop. I use Photoshop for all my photography and astrophotography images, and I use DaVinci Resolve to create this video. The video is a bit longer than 25 minutes, and at the end of the video, I'll take a few questions. So please enjoy.
In this video, I'll review, stack, and process images of a deep sky object. The equipment I used to capture the images were all controlled by Stellarmate installed on a Raspberry Pi device. I'll begin by doing a quick overview of the images in Adobe Bridge. Then I'll review them in Deep Sky Stacker. I'll then stack the images in Deep Sky Stacker and do the same in Sequator. Next, I'll go into Photoshop to check the difference between the stacked images. First, I prepare my folders with appropriate labels, such as lights, darks, biases, and flats. However, in this video, I'll only be working with light images. In Adobe Bridge, I do a quick assessment of the files looking for elongated stars, star trails, noise, distortions, and light pollution. I also screen for aircraft and satellites. What I'm looking for is something like this: clean round stars with light rays and very little distortion. I delete files that have unexplained anomalies. And I also delete files with elongated stars. And the remaining files look fine, so I'll keep them all. In Deep Sky Stacker, I screen the images more carefully, deleting any files I don't want. I also check the noise levels in the dark and bias files and the vignetting in the flat files. Since I'll only be stacking light files in this video, I've only included one bias, dark, and flat file. Sliding the slider over allows me to see the noise levels in the dark and bias files and the vignetting in the flat file. In the light files, I look for any distortions or anomalies that might affect the final image. Now I need to register the files, which places a number in the score column. The score gives me an indication of the quality of the image. First, I select all the light images I intend to stack and deselect the bias, dark, and flat images here because I'm not stacking these. Now I'll register the files I've selected, and I'd like to check the score before I stack them, so I'll deselect this. Since I've checked all the files I intend to stack, I'll leave this at 100%. Now I'll check the star detection threshold to get an idea of how many stars it will detect. Then I check the stacking parameters to make sure that the final stacked image will be a TIFF file. In the recommended settings, I select the best options I think will give me the best result. You can play with these options in the recommended settings to see what the effect would be. I leave all the other parameters the same, and then I go ahead and register. After I register the files, I change the sort order of the score column to check for the lowest and highest scores. Then I quickly review the images with the lowest scores to determine if I should throw them out. I'll look for distortions or anomalies that might skew the final image, but in this case it seems as though they're all okay. Since the stars in the image with the highest score are similar to the stars in the image with the lowest score, I'll go ahead and stack them all. So I click on Stack Check Pictures, and then I review the recommended settings once again to make sure nothing's changed. And then I click OK. Deep Sky Stacker then displays the final image for you to make adjustments, but I leave my adjustments for Photoshop. The final stacked image is saved in the same folder as the other images, and it's named Autosave TIFF. Now I'll open up Sequator in order to stack the images and compare with Deep Sky Stacker. I'll load the star images or light images, and I'll disregard the autosave that Deep Sky Stacker created. You'll notice that Sequator has selected one of the images as a base image. Noise files, that is bias and dark files, can also be included for noise reduction, as well as flat files for vignetting correction. Now in output, I need to type a name for the final stacked image. The stacked image will be created in the same folder alongside the autosave file, and I'll compare the two in Photoshop. Next, I go to Composition I leave the star alignment option and select the best pixels. This option is best if you have more than 3 images to stack. Of course, you can play with these options to see what the desired effect or result would be in the final image. I'll choose to remove dynamic noises and leave the other options as they are, then start the stacking. After it completes, it displays the final image. Then I switch over to Adobe Bridge to view the stacked images. I look at light rays around the stars, nebulosity, and consistency in the shape of the stars. If I'm satisfied with the resulting images, I'll open them in Photoshop to do a more detailed examination. I'll begin with the Sequator file. The image files open up automatically in Photoshop. If we go to Image Adjustments Equalize, we can stretch the image to get a better look at the nebulosity. This Sequator file shows a fair amount of nebulosity. Now I'll switch back to Adobe Bridge and open up the Deep Sky Stacker file. I'll open up the autosave file created by Deep Sky Stacker. By default, Deep Sky Stacker creates a 32-bit file, which I've got to reduce to 16 bits to take advantage of all the Photoshop adjustments. I'll check the various methods Photoshop uses to convert the file and select the best method. In most cases, I find the default good enough. If you look closely, you can see a little vignetting in this image. Next, I'll use the Equalize adjustment to have a look at the nebulosity. You can see the nebulosity looks more pronounced in this image than in the Sequator image, so we'll process both and compare them just the same. Back in Adobe Bridge, I'll open up the autosave file in Camera Raw to make some first adjustments. I'd like to keep this nebulosity visible while I make the adjustments. The temperature can be adjusted to make the image cooler or warmer. I also like to keep these light rays coming off the star visible as I make the adjustments. I make all the adjustments necessary to enhance the image. By looking at the histogram, I try not to overexpose or underexpose the image. I prefer to make the curve adjustments in Photoshop. I generally try to keep the image looking softer rather than too sharp. Color grading allows you to adjust the luminosity and the colors if necessary. Since all looks well, I'll open it in Photoshop. Now here in Photoshop, I'll zoom in to have a look at the nebulosity around these stars, and then I'll adjust the levels. I'll do the adjustments in such a way as not to clip any detail. Next, I'll make adjustments to the shadows and highlights. And I'll adjust the mid-tone for a better contrast. Next, I'll have a look at the exposure and gamma correction. I'll do what I can to make the nebulosity stand out. I'm happy with this. Now I'll make an S-curve adjustment to bring out the nebulosity more. I've also installed a filter from Pro Digital software called AstroFlat Pro that allows me to remove the gradient. These sliders allow me to make the subject stand out more against the background. I can also clean up the edges and zoom in and remove some of the noise. And here is the before and after comparison. Now I'll save this image as a Photoshop file and I'll begin the processing of the Sequator file. This is the file that was stacked in Sequator. If I go to image mode, you'll see that Sequator has already stacked this image at 16 bits per channel. So no changes are necessary to be able to take advantage of all the adjustments in Photoshop. I'll begin by adjusting the levels, taking care not to clip any detail. The goal is to enhance the subject against the background. You can actually adjust and readjust the levels until you're comfortable with the results. Now I'll go directly into AstroFlat Pro to enhance the subject against the background. I'll adjust these sliders to enhance the nebulosity. And click OK when I'm ready. I'll now adjust the shadows and highlights. and then make an S-curve adjustment. Now we'll compare the two images. Sequator and Deep Sky Stacker. We'll zoom in to get a better comparison. The Deep Sky Stacker image seems to have less noise and seems smoother, so I think I'll go with the Deep Sky Stacker image. And here's the final image.
All right, so do we have any questions for Reza?
Yes, our first question comes in from Aaron. Aaron wants to get a Pi, but they seem to be out of the 8 GB models. Does anyone have any experience with a 4 GB version, and does it still work well?
Yes. I've been using the 4 gigabyte version, and I haven't had problems except with my low-end Canon camera that I started with. There seemed to be a driver issue because I use StellarMate, and StellarMate uses the Indie drivers, and I found a bit of a glitch when using the camera. So for some reason it would just shut off. But I haven't actually explored using better model cameras or cameras specifically designed for astrophotography. So I do have to explore that a little bit more equipment. Other than that, I haven't had any problems with running StellarMate on the Raspberry Pi 4 to coordinate the equipment.
Thank you. This question also comes in from Aaron. When creating flats, his tend to be taken when it's getting a little bit too light outside, and the blue is very right shifted next to the other colors. Does this degrade the value of the flat?
Well, I've experimented with flats using a white t-shirt and the light from my iPad. And, it's a trial and error issue. I haven't really nailed a particular method of doing it the best way. But it's trial and error pretty much. But I see a number of people that use the white t-shirt method to filter the light, and that seems to work. It's worked a little bit with mine. I still have more experimenting to do in that area.
Thank you. Lewis would like to know, can the image adjustments also be done in apps like GIMP?
Well, I've used GIMP. I started in Photoshop, so for me, Photoshop just comes naturally. I've used GIMP as well, and GIMP seems to have a lot of great features. So yes, you can use GIMP. Other amateur astronomers, astrophotographers have done some pretty remarkable work using GIMP. So I'd say yes, go ahead and try that, because it does work.
This question comes in from Eric. What kind of Raspberry Pi do you use?
The Raspberry Pi 4, and like I said, I've installed StellarMate, to be able to coordinate the equipment.
Another question from Aaron. Is there a minimum FWHM value that you shoot for when looking for quality lights?
Well, ideally you want to get the best possible image, yes, when you're out in the field. So I say I don't remember exactly if it's the higher value or the lower value, but definitely keep an eye on that for sure, because you do want to capture as much detail as possible without clipping any of the data.
This question also comes in from Lewis. What method do you use to transfer from the Pi to your desktop?
I use Wi-Fi. I use VNC viewer, and on the Raspberry Pi, I've got the VNC server set up.
Cool. How much does AstroFlat Pro cost?
I don't remember the exact figure, but it was very reasonable for what I get out of it.
This is our last question coming in from Ralph. With the manipulation of the image data, is there a loss of scientific data?
No. It's all about signal to noise ratio, and as far as the scientific data goes, you know, could you be more specific? Because all I can say is that I'm just in it for the photography.
Okay, thank you. That's it for the questions.
Reza, thanks again for the video you created and the comparison between Sequator and Deep Sky Stacker. That's very interesting and useful. And I believe your video is available on your YouTube channel, correct? For future reference, if we want to go back and review it, it's available on YouTube. And of course, it'll also be available on the Toronto Centre's YouTube channel if you want to watch the tutorial again.